Now let us look at some examples of upper bound, that is big O. Our big O কিছু উদাহরণ দেখে নিই. So if fn is 5n squared plus log n plus 1, upper bound of this equation will be, or the big O of this equation will be n squared. And for c greater than 5, this is because when we multiply c with n squared, by definition we know that c times gn must be greater equals fn. So if gn is n squared, c must be greater than 5 so that this equation satisfies. Now, if fn is 100n, then big O of n for this equation is, the big O is n, upper bound, for c greater equals to 100. And if fn is 50, now this number is independent of n. এই equation n কিছু নাই, মানে this equation is not independent of input. Therefore, we say big O of 1. This is also known as constant time complexity. এখন আমরা big omega analysis দেখি. Big omega explanation হচ্ছে just the opposite of big O, where there is an asymptotic function gn such that c times gn is smaller or equals fn, which means it lower bounds fn. So if this is fn, gn must be lower bounding fn. Okay? এবং gn কে বলা হয়, big omega কে বলা হয় best time complexity, best time case complexity, অথবা এভাবে ধরা হয় যে minimum amount of time required by the algorithm to produce its output. So it's known as best case complexity, best case time complexity, which is also the minimum amount of time required by the algorithm to produce its output. Now let us look at a few examples of lower bound. So if fn is 5n squared plus log n plus 1, the lower bound of fn will be log n, or n squared for c less than 5, because we have seen in the previous equation or slide that for c greater equals to 5, it's big of fn, big of n squared, right? As long as c is less than 5, this n squared lower bounds this equation, so we can call this the lower bound. And also this one, log n, because log n is the least dominating factor. N squared is the most dominating factor and log n is the least dominating factor. Therefore, this will always be lower than this fn. Therefore, আমরা এই least dominating টাকেও আমরা lower bound বলতে পারি অথবা best case বলতে পারি. Now 100n এর জন্য big omega of n হচ্ছে big omega হচ্ছে n for c less equals 100, and same for this one, as this is not dependent on n, so we just simply say big omega of 1. Now big theta analysis হচ্ছে big theta is an asymptotic function gn such that some constant c1 times gn is smaller than or smaller equals fn, and if I multiply some other constant c2 with the same asymptotic function gn, it's greater than fn, which means if this is fn, gn is such a curve that when you multiply gn with c1, it lower bounds fn, and when you multiply another constant c2 with the same equation gn, it will upper bound fn. Now this, something like this, to find this gn, is very difficult because the algorithm must be tested with all possible distribution of input. তার মানে হচ্ছে, if linear search is the algorithm, so we have to try with every possible distribution. মানে হচ্ছে, uh, let's say linear search, I'm looking for the number 5. So এখানে 5 প্রথমে পাওয়া যাবে, তারপরে এখানে 5 দ্বিতীয় ঘরে পাওয়া যাবে, এখানে 5 তৃতীয় ঘরে পাওয়া যাবে, এরকম করে সব রকম ডিস্ট্রিবিউশন দিয়ে দিব আমি অ্যালগরিদমের মধ্যে, এবং প্রত্যেক ডিস্ট্রিবিউশনের যে টাইম কমপ্লেক্সিটি ওগুলো আমি সাম আপ করব and then divide it with the number of inputs. So it's very difficult and rarely used because average time, দেখা যায় most of the algorithms, average time is very much close to big O, which is the worst time complexity. তো এই নিয়ে এই লেকচারে আমরা মোটামুটি asymptotic notations and asymptotic analysis মধ্যে আমরা জানলাম. In the following slides, we will uh, look at a few more examples, and then we will be finding out big O and big omega of algorithms.